My name is Yash Sharma. Welcome to Machine Learning in the Sciences, the podcast where we explore the intersection of cutting-edge, data-driven technologies and scientific research. In each episode, we'll delve into how data-driven technologies are being utilized in the real world. From biology to computer science, chemistry to ecology, we'll bring you insights from leading experts in the field and examine the potential impact of these exciting advancements. Stay tuned for some amazing conversations. Hello and welcome to the very first episode of Machine Learning in the Sciences. I'm your host, Yash Sharma, and we're starting a journey into the fascinating intersection of cutting-edge artificial intelligence and scientific research. We aim to explore how machine learning is revolutionizing not just the world of research, but how we comprehend the universe around us. Today, I am privileged to host an incredibly unique guest, Corey Wade. Corey isn't your typical mathematics high school teacher. His diverse academic background with a master's degree in pure mathematics, a master of fine arts in writing and consciousness, and a bachelor's degree in history sets him apart. Corey has founded Berkeley Coding Academy, which specializes in educating students of all ages in machine learning and AI. He has woven together the abstract realm of mathematics, the philosophical intricacies of consciousness, and the rich tapestry of history, all while maintaining an influential presence in the world of education. Notably, Corey is the highly acclaimed author of the book Hands-on Gradient Boosting with XGBoost and Scikit-learn, a must-read that's found on virtually every machine learning enthusiast's reading list. In his book, Corey has successfully demystified the complex world of gradient boosting, making it more accessible for everyone. From educating young minds in the classroom to authoring seminal works on machine learning, Corey has been at the forefront of expanding our understanding of these intricate fields. Today, he joins us to share his unique perspective on machine learning's evolution, its current state, and the future it might hold for AI and education. So whether you're a researcher, data scientist, or science and technology enthusiast, sit back and get ready for a mind-broadening conversation. Together, let's delve into the boundaries of machine learning, consciousness, AI, and education. Welcome to Machine Learning in the Sciences, Corey. It's an absolute pleasure to have you here.
Thank you. Happy to be here, Yash.
So I guess let's start off with the first question. So can you recount the moment or experience that, initially ignited your passion for machine learning?
Yes. So I remember wanting to stay up all night, but of course, eventually people get tired. As I was waiting for, it was an NLP machine learning algorithm to finish. And what this was doing, it was trying to predict reviews on Amazon, whether they were helpful or not. And so this was the first time in which I had all the data going. I tested it on a smaller subset of the data, and I was really excited to see what the results would be. Mm-hmm. But I had to sleep to do that. And so I remember waking up first thing in the morning and feeling so excited as my computer had been churning all night long to see what the results were. And, they were pretty good. And that was the first major project that I did in machine learning.
Nice. Yeah, I definitely can, relate to those experiences. I remember working on projects, the drone project. I remember staying up until 12, until my mom had to come into my room and tell me to go to sleep. But I just remember it was just tunnel vision the whole time, just staring at the algorithm and, waiting for the results to come back. So in your experience, how has your background in pure mathematics influenced your understanding of machine learning algorithms and concepts? And, are there any specific instances you can share where your mathematical insight has proved particularly helpful?
Sure. Well, machine learning breaks down really into two components, you could say. Yeah. There's the theoretical side of it, and then there's the practical side. And so when I'm, say, running algorithms, right, it's input output, I've got the input, I'm waiting for the output. I'm just happy to be doing that. When it comes to deeper understanding, and if you want to look at how do the models actually work, like how does linear regression actually work? And these are questions that I think most people who study these fields do ask, right? Yeah. Like, how do you get the errors? Like, how's it coming up with it? And so having the background in math then allows one to look at the papers and to look at the theory behind it to better understand it. But I will also add that I think my mathematical background also makes my ability to program a little easier, because I found it's actually not as dissimilar as people might think. And I'm talking about here, say, writing a mathematical proof and writing a computer program. And I think having some experience writing mathematical proofs actually gives me greater confidence, and it allows like writing computer programs to be a bit more straightforward.
So do you feel like, when it comes to kind of understanding that full machine learning pipeline and really choosing the right model for the situation, do you think that mathematical experience has, helped you a lot further?
Yeah. I definitely think so. I mean, it's hard sometimes because when we have foundations and we're focused on something else, we're not always consciously trying to make the link between the foundation and the thing that we're doing. But abstract thinking in general kind of unites these fields. And it's not just abstract, it's abstract logical thinking. And for me, like, I actually get really excited about learning more even about how to build the deep learning networks and how to do all of this stuff. But I also teach high school students. And so a lot of the teaching that I do is for students who don't actually have that background. Nevertheless, I have found that the deeper understanding actually allows people to say, and allows me to explain it better because, I do have more to go on, you could say.
Yeah, that's awesome. So how has, the landscape of machine learning changed over the course of your career? And, are there any pivotal developments or breakthroughs that you'd like to underscore?
Sure. When I was first heard about it in context of, within education, people were saying, machine learning is like the new electricity and everybody's learning it. There was like one course. You could take Andrew Ng's course online. That was the first one. Now there are a lot. There are a lot of courses. So that's one huge change. I think, I've certainly over time, we can do more because there's been more computing power. But I think the biggest breakthrough in terms of what normal people do is ChatGPT.
Yeah.
Because suddenly we have something that now everybody can use, and machine learning is now no longer just for the scientists, just for the people studying these subjects. Suddenly it's being consciously used by students in schools. Now, it's not to say that they weren't using things that where machine learning was playing a lead role, like Netflix and all these digital assistants, but people weren't as conscious of it. When they're asking ChatGPT a question, they're fully aware of what's happening. And that I think I think a lot of us, myself included, are generally surprised that say it works as well as it does. And so we're kind of at a new era, I would say, of machine learning where, we can all build models from scratch, but people have done that. And when we now build upon their models and use what they have, it's just a different level that we're starting to see.
Yeah. So then I guess more on the technical side of things, what's been, the biggest breakthrough that's helped you, through either, I guess, teaching students or, programming on your own?
Well, when you're asking about the technical side, are you thinking of things that I've learned or things?
Just developments in the field of machine learning that have, improved our ability as, data scientists to, get better models, get better predictions, stuff like that.
Sure. I mean, I'll mention a fun one. So I've always been fascinated by recommender systems. Okay. And so just to give you an idea, right? Netflix, as I think most people know, it has a recommender system. Most media that we interact with, the traditional media, right, being music, movies, books, when we go online, we're seeing recommendations that are provided. Now, recommenders have come a long way. At the beginning, if you look at the Netflix competition, Netflix was hoping that somebody could improve their recommendations by 10%. And so there was this contest that Netflix put out, and it was worth $1 million. And people were fascinated by this. Why is this worth so much to Netflix. And why is this worth $1 million? That contest in itself led to, from what I've heard, breakthroughs in recommender systems that ended up being way more valuable than the $1 million prize itself. And Netflix didn't even end up using the award-winning prize because it was so complicated. And so, like, for me, I've always had the advantage of, like, when I'm jumping into something and studying it, I can go into that history, look upon the history, and look upon, say, the models that people are using today. Because I'm an educator, I can use things like Surprise, which is a great recommender library that people have built to actually make it easier for other people. And so what we're seeing today is more and more, yeah, you can build it from scratch. There's value in that. But what are the libraries that people have made that are easy to use, that make it fun for students and others to use?
Nice. Yeah. So writing requires a mastery of narrative, emotion, and the power of language. So in what ways has your background in writing influenced how you communicate complex concepts to your students?
It's a great question. There's some different directions I could take that. I think one, so you brought the book, right? Hands-on Grading, Boosting with XG Boost and Scikit-Learn. That's a technical book. So you mentioned I have an MFA in Writing and Consciousness, which is more of a, I don't know, I write poetry, I write a little fiction, some nonfiction about a broad range of topics. My focus as a writer then allowed technical writing to be, to come a little easier, which in turn allows teaching of those concepts to be a little easier, because when writing, like my approach to writing, say that book would be, I do a lot of research, I dig deep, I learn what I can, and then I sit down to write, and I'm trying to communicate kind of the essence of it. And so when you focus on communicating the essence of something, I think that's really key, because it's hard because there's so many details, and it's hard like not to get bogged down in the details. And so for me, it's an ongoing process, you could say, with writing and teaching, and both are similar in the sense that it's all about taking the information and distilling it in a way so that somebody else can learn it more quickly. Mm-hmm. An example I like to give is calculus. When Isaac Newton developed calculus, the top mathematicians of the day could not understand it. Like, this was brand new and it was difficult. I invite anybody to look at the Principia, which was written by Isaac Newton, and you can open that and try to read it to learn calculus. It's very difficult. Okay, we are now several hundred years later, removed from that, where there's been ongoing progress of distilling the key information so that in this day and age, high school students can learn the essence of calculus in one semester, which would have been unthinkable a couple hundred years ago.
Yeah. So would you say that, your writing kind of furthers your teaching ability, and it's kind of like a chain between those two, just, teaching students?
Absolutely, because it's take a concept, like take machine learning. And so how am I going to communicate machine learning? Well, the fact that I've done it teaching and writing, those both influence each other. And so, they're different experiences, but they are comparable. And, I think what's interesting, I can tell you kind of a balance point, is that as a teacher, sometimes I like to go on a little bit and talk about topics more. Whereas with the writing, it's all about being more concise, because you don't want to waste any words. And so I think having a balance between these two is kind of ideal. We don't want to, if you don't say enough, people don't understand things. Yeah. But if you talk about something too much, then it's not efficient.
So then how would you, just describe machine learning in general in a couple of sentences?
Well, it's difficult to do because people have different backgrounds. And for me, I can tell you an article that I want to write, which I have not yet, and I think it'll be one of my most challenging. It's so that my mom could understand it, being someone who has no technical background whatsoever. I think for people who have some knowledge of programming, I would say that, I did not come up with this definition, but machine learning well, think about it like this. If you want to write a program to do linear regression, you have two approaches. You can use calculus to use the least squares regression law and write your code to handle it explicitly. Machine learning, what you do is you randomize the initial values. You randomize kind of the line, okay, the values that are going to make the line. And then you basically use the calculus to then minimize the errors, but you're starting with a randomization. The idea behind machine learning is that computers are learning from data. However, people should understand that we have written algorithms that handle that.
Yeah.
So like people wrote algorithms for, it used to be called statistical learning. So you can say people have written algorithms for machines to be able to, computers to learn from the data. So the more data you give it, the more it learns. What that means is like we're not giving it the parameters in advance. The algorithm is optimizing the parameters based on the data that comes in. And so this is different than explicit programming. You can see it doesn't have a short answer. Maybe I could, it's hard to give it in a couple sentences, but I think a cool example is like, how do we distinguish between a cat and a dog?
Yeah.
Right? My daughter, when she was little, I think her first word for animal, I don't recall, I think it was one of those, and she called everything that. Dog. Like, no, that's a cat. That's a dog. That's a cat. That's a dog. And her brain eventually figured it out. What we learned was that explicitly programming, say a computer program to categorize cats and dogs by giving it the right parameters was virtually impossible. Too hard for us to do. Machine learning provided the optimal solution, which was, okay, why don't we look at it with how the brain works? Instead of us telling the computer what a cat and a dog is, let's give it an algorithm that gives it the freedom to choose when we say, hey, this label is a cat, this label is a dog, this label is a cat, this label is a dog. And then it goes in and looks at all the pixels and it comes up with its own connection between the pixels. I think a lot of the genius behind machine learning, it's us. It's the people who have developed these algorithms to allow, say, learning to take place.
Yeah. So now we're going to transition to break. My name is Yash Sharma, and I'm joined with Corey Wade. And thank you for watching this first half.
Thank you to the City of Montessorino for their continued support of KCAT Public Media. The City of Montessorino has enabled KCAT to inspire, educate, entertain, and inform our community through the magic of television and digital media for over 38 years. Thank you.
Welcome back to Machine Learning in the Sciences. We are back from our break. So, Corey, the book Hands-On Gradient Boosting with XGBoost and Scikit-Learn is on every machine learning list. In your book, you tackled some gaps in machine learning. So what drove you to address these specific gaps, and why do you believe that they are crucial to the development of the field?
Sure. So I was actually recruited to write this book by Pack Publishing. So I'm the co-author of the Python workshop with Pack Publishing, which was a successful book. And I wrote the introductory chapter on Python and the last chapters on data analytics and machine learning. So they knew me as a machine learning author. And this came to me at a time when I had some extra time, was transitioning. And so I was excited to do research on XGBoost because I had heard so much about it. And so let's talk a little bit about XGBoost. So extreme gradient boosting. XGBoost made a name for itself in Kaggle competitions. So the Netflix competition, which we talked about earlier, kind of paved the way for Kaggle competitions in general. So a Kaggle competition is a machine learning competition that anybody can join, and they often offer really good cash prizes. The competition that comes to mind was there was a competition to verify the Higgs boson. So we're talking about the Higgs boson was discovered, I don't know the exact date, about 10 years ago, and people referred to it as the God particle. They call it that because it was a missing piece to the standard model in physics, in which, like somewhere along the way, you have to account for mass.
Yeah. Because
if you're starting at a universe without mass, when do you account for mass? I'm not an expert in these, in physics, at that level, but that's kind of like, I think, why they call it the God particle and why it was such a big deal when it was actually discovered. So, and also just to mention, like the discovery of the Higgs boson today, like when we're talking about the cutting edge of science, it's data collection and data analysis, because they're smashing particles together in the Large Hadron Collider, and then how are people interpreting those smashes? It's all data. And so, you know, it's a world of big data, like in the world of science today. And so they found the Higgs boson, and then they wanted to verify it, and that was actually a Kaggle machine learning competition. And so this was, at the time, XGBoost was actually developed. XGBoost stands for Extreme Gradient Boosting. Gradient boosting is a tree-based machine learning ensemble method that is a little different than, say, random forest, which are more traditional ensemble tree-based methods. So just to give a brief idea, if you have a decision tree is like a game of 20 questions. And so that is a machine learning model. You have a bunch of, say, columns of data, and then you can ask it questions like, I can say, hey, is the house by the ocean or not? Does it have more than 3 bedrooms or less? And you can follow these chain of questions until you get to a result. The house then is going to be worth, say, $600,000 or something. Or in the Bay Area, 1.6 million. And so that's a decision tree. Random forest is like, hey, what if we randomize it a little? Instead of using one decision tree, take 100 and then average the results. Won't they give us a better result than it usually does? Gradient boosting is actually an advancement on that, and usually performs better, though not always, because you learn from the errors of each tree. So in a random forest, you're no better than the individual trees. But in gradient boosting, it trains on the residuals, it trains on the errors. And so the idea is you start with just a tree that's a little bit better than 50-50, and the model is based on learning from its errors. And so gradient boosting is a general tree ensemble method, and extreme gradient boosting kind of puts in the bells and whistles, you could say, to make it as strong as you can. And so XGBoost is a specific library that was developed by Tianqi Chen from the University of Washington, and it won that Kaggle competition. So XGBoost verified the Higgs boson, and from that moment forward, XGBoost was winning most of the Kaggle competitions. And this was significant also because XGBoost is not a deep learning model. And it was pretty much deep learning models or XGBoost were winning. And I will also say this in connection with Kaggle competitions. In Kaggle competitions, you have typically thousands of competitors. And so when a model is winning a Kaggle competition, it's beating out typically hundreds of other models. You want to pay attention to models that are winning Kaggle competitions. XGBoost was winning Kaggle competitions, and guess what? To my knowledge, there was not a single book in print about it. And so I was excited. I've never had it actually verified, but I believe that it is the first.
That's why it must be so popular. So with the pace of machine learning advancements accelerating, how do you stay on top of new trends, innovations? Do you follow a specific routine or use certain resources that you'd recommend to other people?
Yeah. I will say this: it's tough because the field changes so quickly. Knowledge quickly becomes outdated. It's like what you knew a few years ago is not the new thing. Conferences can be great. There's the Open Data Science Conference. I've presented at that before. When going to a new conference, people present what's new. I use some of my own study sites like DataCamp. I use to kind of keep up. DataCamp has a lot of professionals. Eventually YouTube learns from people's, what they like. And so I'll pick up sometimes the new things just on my YouTube channel because I do, pay attention. I'm also a traditionalist. And so I do online classes with MIT. And though it's not always, say, cutting edge stuff, you're getting what professors are doing, having colleagues, or friends who are connected in the field, and staying a little bit abreast of what they do on LinkedIn. I think it's really about you don't want to necessarily learn this stuff in isolation. I think it's fine to do when you're just getting started, but there's a lot of interest kind of in the world and what people are doing. And, when you hear about new things, you follow up on it, you look into it, right? And like generative AI is huge because that's sort of like what ChatGPT is a version of.
So as someone who teaches complex mathematical concepts, how do you make machine learning more accessible and, less intimidating to your students? More specifically, because we've already covered this a little bit, could you share some, teaching methods or strategies that you specifically use?
Well, I'd like to tell students, someone reminded me of this analogy recently that we used originally with our first machine learning cohort at Berkeley Coding Academy, which is that we teach students how to fly jets, not necessarily to build engines.
Yeah.
Okay, so I go away from the math. My students, typically my high school students, have not had calculus. They have not had linear algebra. And so, something that's too mathematical is not going to work. Instead, I focus on programming, right? Learn how to program in Python. Here's how you program in Python. A specific technique that we use at Berkeley Coding Academy is, number one, we code from scratch. And so we have students start with blank notebooks. And that way, instead of us feeding them like all the code, then they can develop some confidence in going from nothing.
Yeah.
But, right, we also code together. And so that's another principle I use. Okay, you want to learn how to build a machine learning model, let's do it together. And I try to explain like the lines of code, what they mean, what we're doing. And I also try to simplify it as much as possible.
Yeah.
So you can go online sometimes, use Stack Overflow certainly to, come up with solutions, say, to problems along the way. Go on Stack Overflow. And sometimes you can get great solutions, but they can also be very complicated. Yeah. And so I try to say, okay, what's the fewest lines of code that we can make a machine learning model in and teach it like that? Because that way, we're not like weighing down people with too much code. And we do a general, let's code together. Okay, I'm going to help you. I'm going to lead you. I'm going to show you how to do it. But then after that, we say, okay, now it's your turn.
Yeah.
Now you try this using another data set. And then we're there to help them along the way.
So as we look into the future, what role do you envision for AI and machine learning within the education sector? Can you share some potential scenarios or use cases on how AI could transform the learning experience for students?
It's time, right? I mean, ChatGPT happened, right? We can't go back. Just to give you some context, I've already been asked to give a training for next year with another teacher. I talked to a professor, like a history professor. They're going to just do a lot more tests because suddenly, like, everyone's aware that students have access to this AI that can do a lot of the quote homework or projects for them. So education has to change right away. I personally think that we need to be including things like ChatGPT as a part of the process. Just to give an idea, you can have ChatGPT write like a Shakespearean ode about basketball.
Yeah.
And it's kind of cool and fun. But then, as an idea of an assignment, right, you could then have students modify it. Have them show you like what they got with ChatGPT and then to make their own corrections. You can't stop AI, and I don't think we want to.
Yeah.
I think sometimes like it gets a bad name because of certain people's opinions, and then Hollywood, where there's like this world of AI. I think that I did finally get, I'm like, what is the fear of AI? And I finally got it. And so the fear is generally that if somebody wants to commit evil in the world, and there are always people that have wanted to do this, that there's a new medium besides, the technology of physical destruction.
Yeah.
The idea is that it would be AI. However, what I see is that most people who live in the world don't want to do that. They're working, to try to make the world a better place. And so I think it's in our best interest as a society to actually equip students, not just to be able to use the AI, but to be able to build it. And that's where like I like to make the distinction, because students, like my students, I have high school students, right? They're on their phones a lot, right? I think a lot of us are. Can you program that? And I think that's the direction that we need to be taking, because there's a natural interest in the devices. So it seems to me that education needs to be a place where we start to incorporate AI. Like, even you and I talking right now, it's limited because we're only using our brains, right? We're not also using, say, a computer. And I think we are already at the point where people do use their phones and computers as natural extensions of their brain, because we can quickly look things up. We're quickly connected to new things. And I think potentially the greatest benefit of this is that we're going to change what education actually is.
Yeah.
Because why, like, just to give a thought, why do we live in a world in which students benefit from having ChatGPT do their homework for them? There's a fundamental problem with that. And it could be that it's because we're forcing students to do things that they don't want to do. You know, like when it comes to something like Berkeley Coding Academy, students want to be there.
Yeah.
They want to learn AI. And so they're not trying to look for like a shortcut. And I just really encourage like all people involved in education to start to take courageous steps and start to step back, look at like what education is and what the purpose of it is.
Yeah.
My daughter is 7. I want her to grow up in a world where, you know, she's using technology and learning from the technology and becoming like a better and smarter human being than we are because of it. I don't want to like deprive her of that technology because it's too powerful. I don't think that's the right approach.
Okay. And I think I'm going to ask one last question, and I guess we'll keep this short. So, you know, in your studies of consciousness, you've undoubtedly explored the question of what makes a being conscious. So do you believe that AI, regardless of how advanced, could ever achieve true consciousness? Why or why not?
I think it's a great question. I think is it the biggest question in connection with AI? Perhaps. I think life has a spark.
Yeah.
It has some kind of a spark. Like you and I are biological, right? And there's this long biological history. And I think consciousness has some kind of a spark. When I write a computer program, I'm telling it what to do. Even with machine learning, when it is delivering the parameters of a model, I'm the one who's implementing that algorithm and giving it the context. However, you know, I think that there's something I think we don't know. We only know what we know in terms of like, we know how human beings have evolved and we know where AI is today. Personally, I think these two pathways converging is going to be very fascinating. I think perhaps a bigger question is like, what is consciousness and why is it important? Because I think sometimes we have different ideas of what consciousness means, but I don't know. I like to think of spark of life, and I'm not convinced that a robot like necessarily has that, but I'm also not entirely convinced otherwise. I think it's really exciting not to know and to find out, find out where it's going to take us.
All right. Thank you so much for coming to the Machine Learning in the Sciences podcast. So grateful to have you here. For those of you in the audience, Corey is the founder of Berkeley Coding Academy, where he teaches high school students machine learning and AI. And he's also written the book Hands-on Gradient Boosting with XGBoost and Scikit-learn. So please be sure to check that out. Thank you for watching, and I'll see you in the next episode. Thank you, Corey.
Thank you.
Thank you so much for tuning in to this episode. We hope you'll join us again soon for another episode of Machine Learning in the Sciences. Before we sign off, we'd like to give a special thank you to Zach Benitez and the rest of the team at KCAT TV 15. I'm Yash Sharma, and keep exploring the exciting world of machine learning.